flags, memory management register, CR0, CR3 means control registers, task registers, debug register, and a test register. These are the some of the system registers. We will see the flag, system flags. Flags, these are the carry flags. When you are the 1 or 0 indicated, that means they are which are not defined or which are unused now. Parity flags, auxiliary flag, zero flags, sign flag, interrupt flag, overflow flag, IO privilege levels, nested task flag, resume flag, and virtual memory at 0 at 6 flags. These are the some of the flag systems. Okay, system flags as shown in a figure. Control register. Intel 8036DX has three control registers which are of the 32-bit CR0, CR2, CR3 to hold the machine state of the global nature. These registers along with the system address register hold the machine state that affects all the tasks in a system. The control registers which are shown as in the figure CR0, CR1, CR2 and a CR3. CR0 in which 5 bits are shown here and our remaining parts are the reserve. CR1 and CR2 which are reserved for the further use. CR3 in which page dictionary based registers are shown in figure. CR0 machine control register. CR0 contains 6 defined bits to control and a status purpose. The low order 16-bit of the CR0 is defined as a machine status word. To operate only on the low order 16-bit of the CR0, LMSW and SMSW instructions are used. To operate the instructions, these on 16-bit CR0, these two instructions are used, LMSW and SMSWs. For 32-bit operations, the system should use the move or CR0 register instructions. CR0 machine control register. CR0 contains 6 defined bits to control and a status purpose. The low order 16-bit of the CR0 is defined as a machine status word. To operate only on a low order 16-bit of the CR0, LMSW and SMSW instructions are used. CR0 machine control register P bit, that is a protection enable. A P bit is set to enable the protect mode. To enable the protect mode, this P bit is used. If the P is reset, the processor operates in a real mode. Whenever the P bit is resetted, that means the processor which is operated in a real mode. MP bit, that is the monitor coprocessor or a math present. Whenever the MP is equal to 0, it assumes that the real floating point hardware is attached to it. That means the coprocessor may be attached to it. MP0 assume that no such a coprocessor exists and will not attempt to use it. That means whenever the MP bit is there, the coprocessor or a math processor is attached with the processor, or whenever the MP is 0, that MP bit is 0, that means the coprocessor doesn't exist and a math processor doesn't attach with the processor. CR0 machine control register bits. EM bit emulate a coprocessor. This bit is set to cause all the coprocessor output to generate the coprocessor, not of available defaults. A TS bit task switch. TS is automatically set whenever a task switch operates is performed. Processor never clear this bit by its own. We can clear it using the CLTS instructions. With the extension time, this bit forms the 80386. Whether the numeric coprocessor is an 80387, a 386 is able to set this bit correctly if itself when a power is applied. A PG, paging enable bit. The PG bit is set to enable the on-chip paging unit. It is set to disable the on-chip paging unit. We cannot change this bit more than once in a running system. That means whenever system is running, we can able to change only the once this PG bit. A control registers CR1 reserved. CR1 is reserved for the use in a future Intel processor. CR2 page fault linear address. CR2 holds the 32-bit linear address that causes the list page fault detach. This address will be helpful to write the page fault handler. Control register CR3, the page directory base addresses. It holds the physical address of the root of the two-level paging tables used when a paging is enabled. Paging table must be a 4 KB aligned. The lowest 12 bit of the CR3 are ignored. As shown in the figure, the lowest 12 bits of the CR3 are ignored. The paging table must be of the 4 KB aligned. It holds the physical address of the root of the two-level paging tables. A debugging registers of the thread 6 allows a data access breakpoints as well as the code execution breakpoints. A debugging register allows code execution breakpoints, also a data access breakpoint. Thread 6 contains the TIX debug register to specify. Thread 6 contains the TIX debug register to specify the 4 breakpoints, breakpoint control options, and a breakpoint status. Debug register, debugging register DR0, a linear breakpoint address is 0, DR1 linear breakpoint address is 1, DR2 linear address breakpoint address is 2, and a DR3 contains a linear breakpoint address 3. Intel reserve not defined, DR4, DR5, which do not define anything for the debugging registers, whereas in DR6 and DR7, a breakpoint status is shown in a DR6, whereas in a DR7, a breakpoint control is shown, as shown in a figure. A linear breakpoint address register. The breakpoint address specifies are a 32-bit linear addresses DR0 to DR3. While debugging, a Intel 386 hardware continuously compare the linear breakpoint addresses in a DR0, DR3 with the linear addresses generated by executing the software. If match the found, it an exception one is generated. Can you understand all these things? While debugging the 80386 hardware continuously, it compares the linear breakpoint addresses in a DR0, DR3 or a DR3 with the linear addresses generated by executing the software. If a match is found, whenever the match is found, an exception one is generated. A linear breakpoint address that is a DR6. It is also called as a debug status register. DR6 also called as a debug status register. 80386 sets appropriate bits in this register to inform you the circumstances that may have caused the last debug fault. These bits are never cleared by the processor. We can clear it manually or writing on into it. This bits never be cleared by the processor. We have to clear it manually on writing on it. B0 to B3 indicates the breakpoint hit. BD break for a debug register access set when a exception one handler is evoked by an illegal reference to one of the debug register. BD point is set to the one when a exception one handler is evoked by an illegal reference to one of the debug register. BS break for a single step and a BT break for a task switch. Thank you friends for the lecture.